Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers, completing the square with a leading coefficient that isn't 1. Students try to rush it, make one small algebra slip, and suddenly 3 method marks vanish. Sound familiar?
That sounds painful. So in 2 minutes you promise we fix that one slip and save marks?
Exactly. Promise, by the end of this episode, you'll have one clear method for completing the square every time. You'll know the single algebra mistake to avoid that costs marks, and you'll have a 10-second check to catch most careless errors. Let's work through this step by step.
The concept. Start with a quadratic in standard form, ax squared plus bx plus c. Completing the square rewrites it as a times x plus h squared plus k. Why do we do that? Because that form tells us the vertex directly, the turning point, and shows axis of symmetry. It's not magic, it's algebraic rearrangement.
Step 1. If a is not 1, factor it from the x squared and x terms. So for ax squared plus bx plus c, you write a into x squared plus b over ax plus c. Step 2. Inside the bracket, take half the coefficient of x, that's b over 2a, and square it. Add and subtract that square inside the bracket so you haven't changed the expression. Step 3. Factor the perfect square and move the subtracted piece outside the bracket, remembering to multiply by a.
Can you say that with an example? I always get confused when a isn't 1.
Good question. Let's keep the concept clear with symbols first, then a worked example. Starting from ax squared plus b over ax plus c, we add and subtract b over 2a squared inside. A, x squared plus b over ax plus b over 2a squared minus b over 2a squared plus c. The first 3 terms form a perfect square, a, x plus b over 2a squared squared. The leftover term is minus a times b over 2a squared squared, which simplifies to minus b squared over 4a. So the whole quadratic becomes a, x plus b over 2a squared plus c minus b squared over 4a. That gives vertex at x equals minus b over 2a and y equals c minus b squared over 4a. Let that sink in.
So the axis of symmetry is x equals minus b over 2a. That matches the formula for the vertex from the quadratic formula, right?
Exactly. Same information, different forms. Completing the square reveals the turning point and makes graphing or minimum-maximum questions straightforward. Now let's apply it to a higher tier example, so you can hear where marks are picked up.
Worked example. Solve 2x squared plus 8x plus 5 equals 0 by completing the square. Step 1. Factor 2 from the x terms. 2 times x squared plus 4x plus 5 equals 0. Step 2. Take half of 4, that's 2, square it to get 4. Add and subtract 4 inside the bracket. 2 times x squared plus 4x plus 4 minus 4 plus 5 equals 0. Step 3. Write the perfect square and simplify. 2 times x plus 2 all squared minus 4 plus 5 equals 0. Expand the bracket for constants. 2 times x plus 2 all squared minus 8 plus 5 equals 0. So 2 times x plus 2 all squared minus 3 equals 0. Move the constant. 2 times x plus 2 all squared equals 3. Divide. X plus 2 all squared equals 3 halves. Take square roots. X plus 2 equals plus or minus square root of 3 halves. Finally, x equals minus 2 plus or minus square root of 3 halves.
Nice. Everything follows. But where do examiners award marks on a question like that?
Exam technique. Here's where the marks live. For this example, a typical 4-mark question would be M1 for the correct start,
factoring out the two or showing an equivalent rearrangement, M1 for forming the complete square in the bracket, M1 for isolating the squared term and taking square roots correctly, and A1 for the final correct answers. Even if you don't finish, those early method marks are easy to claim if you write the algebra clearly. Write it down, don't just think it.
Common marking traps. The single algebra slip I mentioned is failing to multiply the subtracted square by the factor a when a doesn't equal 1. In our example, we subtracted 4 inside the bracket, but that is actually minus 2 times 4 equals minus 8 when moved outside, which we accounted for. Students who forget that multiplication lose an M1 and often an A1 too. Another trap is losing the plus-minus when taking square roots. That's an easy lost mark.
So if I run out of time, what do I write to maximize marks?
Great exam strategy. If time's tight, do these 3 things and you're likely to secure most method marks. 1. Show the factor step. Write a into x squared plus b over ax plus c. 2. Show the square you added, plus b over 2a squared. 3. Write the factored perfect square even if you don't finish the arithmetic. Examiners give method marks for the correct method even if you haven't evaluated the final roots. Marks are there for the taking.
The quick win, 10-second check. After you find an answer, pick one root and substitute it back into the original equation. It takes 10 seconds and catches most sign and arithmetic errors. For our example, pick x equals minus 2 plus root of 3 over 2. Substitute into 2x squared plus 8x plus 5 and check the value is approximately 0. If it's not, you've likely lost a sign or missed a factor.
What if substitution looks messy with surds under time pressure?
Good point. You don't need an exact substitution every time. Do a sign or order of magnitude check. Plug the approximate decimal for the surd. For root 3 over 2, use about 1.225. So x approximately equals minus 2 plus 1.225 equals minus 0.775. Put that into 2x squared plus 8x plus 5 and check it gives something very close to 0. That quick numeric check catches 90% of careless errors and takes 10 seconds. Don't skip the check.
A second quick habit, always check the axis of symmetry when you complete the square. From a x plus h squared plus k, the vertex x equals minus h. Compare that to minus b over 2a. If those don't match, you've made an algebra slip. 2 tiny checks, substitution and axis agreement, will save marks under pressure.
Any tips for practicing this so it becomes automatic?
Yes. Practice 3 things in every question. 1 easy completion where a equals 1, 1 where a does not equal 1 and gives neat numbers, and 1 where surds appear. Time yourself. Aim to complete the square and check in under 3 minutes for non-surd cases. On the website, you'll find 3 graduated practice questions with worked solutions you can download and print. I'll drop the link in the show notes.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.